Hello and welcome to another episode of the ChessTDD series. In this one, I'm going to start off by, and I mentioned it in the post, but if you don't know what I'm talking about, if you're just watching YouTube, go back and check out post 18 in the comments. It was pointed out that I inadvertently introduced some behavior that wasn't buggy all the tests were passing, but it might be weird. Specifically in move piece, I had abstracted out the set piece method that I said would be okay to call with a null argument, and that would be a private method to this class. And then an add piece, I didn't want to let users pass in a null. So during the course of refactoring, I meant to, in move piece, have this be a function of adding a piece with the actual API and then removing it. But what I did instead was allow set piece, which is not going to directly produce any problems, but it's weird in that it will get a null piece, it will set a null piece, and then will throw only when I try to remove the piece. So I made a simple change here in order to get this going red. Basically, I checked for the exception type. Add piece was generating a null argument exception, so I checked for that, which failed. And then I made the test pass by changing add piece to set piece. So we're back to normal now. That's the kind of thing that might have come up in a bug later. So on to the next thing, crisis averted, good case made for code reviews right there, or perhaps pair programming, where I wouldn't have even checked in that rather strange behavior. So next up, I'm looking at this weirdness I noticed a few episodes ago, where I think, meant to introduce a variable for board size and then a constant for default board size. So I'd like to get around to letting us have a different board size than 8. I've hard-coded 8 in twice. I don't know if I'm using this default board size. So I went about getting that right and kind of figuring out a way to tackle it here. And one of the things I did throughout the course of this particular episode, and I have the advantage of actually, for once, I just coded this like 15 minutes ago, so I remember pretty well what was going on. I spent a good bit of time doing some Boy Scouting and factoring at least all the board tests to this new paradigm. So you're going to see that here. Now that I feel pretty good about this way of writing the test class names that Steve introduced me to, I'm going to start to go a little more all in and not just do it from here forward. But when the opportunity presents itself, I'm going to factor towards that pattern in general. So here I want to add a test around the add piece method. And in order to do that, I was going to have to go back to this nesting and previous naming paradigm that I've since abandoned. So rather than do that, I'll just take this opportunity to create a new test class that follows the pattern that I have here. And I will move the old stuff over and then add the new in a good spot where I actually wanted to. And this is sort of a perfect example of Boy Scouting that you'll probably find. And for those of you who don't know what Boy Scouting is, this is the Boy Scout principle is leave the code a little better than you found it every time you touch it. So instead of trying to undergo massive refactorings to clean up code bases, just kind of whenever you're, sorry about that, I guess I popped the Windows screen briefly. Whenever you're touching a piece of code anyway, take some opportunity to clean up anything that's unclear, rename, etc. And so that's what I'm doing here. As long as I'm going to write a test, I might as well take a little bit of extra effort and factor it to this new way of doing things. So here I have these flattened out tests with the descriptive class name. And so I'm going to update my verb tense here to match the should construct. So it's saying should throw, should accept, not should throws, should accepts. So once I get that in place and go in and delete it from the old place because I don't want duplication. That, by the way, is why I was doing the copy and paste, because I wasn't looking to duplicate. I was looking to duplicate temporarily to get green and then eliminate, so basically just moving. Now it's time to add an actual test method, I believe, if memory serves. So I'm going to go down here and say that I'd like to see a new behavior here. And I'd like for add piece to result in a valid piece at coordinate 9, 9, when I pass a board size to the constructor, and that's what I'm going to do at the time board is initialized. So when board size is 9 and I'm going to make board immutable in terms of the board size, there's absolutely no sense in making that something that I can change at during the middle of the object's existence. So when I pass in a board size of 9, I should be able to add a piece to the 9, coordinate. So I have a test now failing by virtue of not compiling. So what I need to do is go in here and add a constructor, because board for now just uses the default constructor. So I'm going to declare a constructor here at the top. And what I'm going to do for backward compatibility with all the existing places that I instantiate this, as well as just kind of general common sense and a pattern that I call sensible defaults. I don't know if that rises to a pattern. It's just kind of a notion. Is that I'm going to say if you instantiate a board with no parameter, it's going to default to 8 as the default board size. That's the sensible default. So if you just instantiate a board with no constructor parameter, it's going to be size 8. If you want something else, you have to tell it. And I kind of think that's a nice way with something that has a clear opinionated sort of default like a chessboard. That's a good way to do it. Why make, if 99% of the time you're going to be giving it size 8, why force people using your class to pass in a parameter? So it's a nice language feature of C# that, and a lot of languages, frankly, that you can do default parameters. So what I'm doing here is now I'm successfully passing in the board size, but now I want to, I'm actually asserting that I have the ability to get a piece or add a piece to 9, which is throwing an exception. So what I have to do now is actually have some kind of concept of making the internal array conform to the size that I'm passing in. Right now, it's just set to 8, which is this default. So I'm going to have to move this to the constructor because that's where I actually know about the board size. So I'm going to initialize this array to be of board size, whatever I'm passing in. And then I'm going to figure out why that's not compiling, and it's going to be because I did something dumb, but I still have more problems. So I think I went back in here and I actually did Control-Shift-B a few times to see what the compiler was telling me. And oh, if I actually look at these errors, so here's an instance where before, since I was using a constant, this method could be static, but now I actually need to know the instance-based board size. Then I also had a naming oops up at the top where I think I changed the name of the variable to be piece instead of pieces by mistake. So once I figured that out, it was pretty smooth sailing. So I'm going to put that back to pieces, and then I believe everything compiled. Now I'm still getting an exception, so let's take a look and see why that might be happening. Did a quick build to get rid of the squiggly that was left over. And the reason that's happening is because I'm just initializing the board size to 8 and never changing it. So what I have to do is actually set the internal variable to what's passed in, and everything goes green. And then I'm going to make this guy read-only because I can, and all that talk I just did about immutability would kind of not make a lot of semantic sense if I didn't take advantage of the read-only keyword. So now I have an immutable board size, even though I can change the state of the pieces on it, and that kind of reflects reality. So what I'm going to do now is flatten out this class and rename it. What I started to do, because I mistakenly thought that this test was a test of the constructor, and I actually want to write a couple of sanity checks on the constructor. You can see I started typing it, and then I looked down and said, oh, wait a minute, this really isn't testing the constructor. So instead I renamed it. I think it took me sort of a mildly embarrassing long amount of time to figure out what to call this. It was something like get piece, should. Thought I was testing. I guess I thought the name of the method was retrieve. Harped on this before, but when you're only in the code base once every, I don't know, week or 10 days, you kind of forget these things. So board get piece, give an empty board, I guess. Should. Maybe I didn't like that. Don't remember now. Yes, I thought better of it, and I said given, and then I wanted that all to be one. I don't know, I'm still kind of working out my naming methodology. Don't want too many underscores in the name of the class. And also bear with me because the code base that I'm in day to day in the Java world has sort of a different set of naming conventions around the tests in there. So I've got that in my head. You can't see that, but it's sort of screwing with me. So I decided to move the given into the test initialize method, and then this would be a single line assert. And there might reasonably be more that we want to come back here later and talk about get piece. We shall see. Didn't have anything more to do at the moment because what I wanted to do is start writing a test or two about the constructor. But before I did that, I'm going to engage a little more Boy Scouting here. And as you can see, the root directory of chess.test is getting sort of unwieldy with all these big classes with their names. So there's a lot of testing going on around board. Created a folder and plopped all those things in there. Now I'm going to update their namespaces. And if anyone knows, if you're a CodeRush user out there, or maybe it's a Visual Studio thing, I would love a feature where I could like right click on that folder and just say, make all the classes or all the files in here of this namespace. Anyone knows a way to do that, I'd be much in your debt if you chimed in the comments, either on the YouTube channel or on my blog. That would be very cool. I think I researched this a pretty long time ago and didn't find anything satisfying, but it's been a while since I looked, so yeah. Definitely let me know if you know of that. So, now that I've done a little bit more Boy Scouting and I like kind of the layout of what's going on here a little better, I'm going to add another class, and this one's going to be about the constructor. And when you're doing, micro unit tests, class level tests, it's hard to give the constructor tests a name other than anything other than constructor should, because not going to hopefully have much given in a class instance before you've instantiated it. So what I'm going to do here is I'm going to say that it should throw an exception when passed a negative board size. That's just a sanity check. And one of the important things when you're doing especially like constructor parameter checking for things that are going to go on to be immutable, although even if they're mutable, it makes sense. You want to think about the preconditions for your class. So what is it utter nonsense if I'm passed? Even on the method level, you want to think about this too. Like a lot of times the precondition for a method will be that argument shouldn't be null or something like that. But it's really important with a class because, you're creating an object and you want to sort of fail early if people are doing programmer error things or violating your API contract. So I'm not going to let them make this mistake. I'm going to throw an exception right away and not try to limp along with a bizarre thing like a board size of -1. And early in my career, I used to think it was some kind of favor to try to recover from crazy things that I was past, and I might somehow try to. I don't know what I would have done, but don't do things like that. If your class makes no sense with the argument that you're given, stop. Fail early, fail visibly, fail loudly. Let your callers know exactly what they're doing wrong. Okay, so the next test I'm writing here is that I also want to throw an argument exception on 0. This is a little, maybe a matter of opinion. Writing these two tests, what I did there was a little contrived. So I wrote, throw if it's less than 0, and then, oh, wait, no, I'll change it to less than or equal. The reason I do that is because board size, what you're allowed to pass in, think of this in terms of interesting values. So in the programming world, when it comes to integers, usually your interesting values are 0, 1, and many, and maybe negative, if I were to very broadly generalize. So I'm not going to write separate tests for like -1 and -6, but 1 and 0 or negative and 0, or 1 and 0, or many and 1 and 0. All those things are sort of very different concepts. So maybe in some world, or it's your preference to actually allow a board size of 0 but not negative. So I'd like to call out that intention sort of explicitly in the test class and document that I'm not accepting negative and I'm not accepting 0. I don't have a degenerative board. which is what 0 would be, I guess, and I don't have a nonsensical board, which is what negative would be, or I guess maybe you could say an imaginary board or something. I don't know. Something crazy at any rate. So now, trying to remember what I did here. One of the nice things about this test naming scheme is that I can now get right on top of what I was doing. And this is the part where I actually tried to move a third card. Made this video a little longer. I was all set there to wrap up at the 14-minute mark. But I went on looking here in Camtasia to about 22. And that was because I started to implement this. I finally had enough of the awkwardness of external methods and even internally to the board class itself. Saying get piece at a coordinate and then setting that equal to null, or seeing if it's equal to null, that's just a little awkward for my tastes. And so I didn't give it a ton of thought, and I guess maybe I could have, but it seemed to me a pretty reasonable thing to do would be to expose another Boolean method that would allow you to check if a piece exists somewhere, because I was using it a lot in that context. So now there's another question here too that I might want to think about a little later, at least not at this point. At this point I didn't do anything with it, but if you have a method to check, a public method to check for the presence of a piece, you might want to give some thought to throwing an exception if you get piece and the piece is null. Because now I'm actually exposing a way for people to know that. So do I want to force onto my consumers that they check and then throw if they try to get a null piece? Or do I want to leave it up to them to check for null? Probably 6 of one, half a dozen of the other. Something I don't really feel like thinking about too much now, so I'll defer that decision, see if it becomes relevant somehow. So back to the TDD, trying to give things good names. I'm failing in this void method because I'm throwing an exception. Now I'm passing because I'm not throwing an exception. Here at this point, I decided to do a little better with the naming. Call this piece exists at. Then I got to thinking, well, maybe I want to say does piece exist at. That's pretty clear. Does piece exist at this board coordinate? I really like it when the methods read kind of like spoken English. So now, of course, I have to update my test class name and accordingly the file. If you didn't catch it, there's a refactoring in CodeRush where you click on the class and say, essentially make the file name the same as this. So this is not compiling because it's, as I just mentioned, a void. I'm going to make this a bool, and then I'm going to get this to pass by returning false. You might, in the most pure sense, say that I should have returned true there to get it red, and then false to get it green, but I don't mind the step of going from non-compiling to passing in that case. I mean, return false is kind of the default. Well, not kind of. False is the default Boolean behavior, so I think I've done enough at that point. Now what I'm going to do is, since I've got green, I'm going to abstract out this coordinate, and I'm probably only, at least for now, going to have 2 tests, one for the true case and one for the false case. So I'll just have them use the same coordinate, and here in setup, I'll just I'll set the coordinate to be 1, 1. So in the false case, I'll check for 1, 1 when I haven't added. And then I'll go here and write a test where I add a piece. I'm guessing I probably added a rook since that's what goes there. So I'm going to add a piece to 1, 1, and then I'm going to assert that if I do does piece exist at 1, 1, it should be true. Yep, there's the rook. So add a rook to that coordinate, and then let's assert that a piece exists at that coordinate. And this is starting to be pretty readable. So now all I'm really going to do here is say get piece is equal to null is what I'll return, or I guess not equal to null. There we go. I got it right at the time, but not when I came back to speak about it later. So again, I have to revisit this if we decide the get piece should do something differently, like throw an exception, but I'll leave it for now. I'm also going to do a little bit of renaming here to make, now that I have more of a beat on what I want to call these things. So coordinate to retrieve, coordinate to check. I kind of like that naming scheme. Everything here is getting more readable, you'll notice. And that's something I very much make a point to do over the course of time in my code base, is not just make the code cleaner in the sense of fewer lines and fewer problems and all that, but like that you could come in and read this. I'm not that I necessarily get it perfect all the time, but like here, what I'm doing with this refactoring, I'm going to clean this up. And to me, coordinates to check dot any x, does piece exist at x, or whatever. Equal null, not equal null. These are not very readable concepts. They don't roll off the tongue when you're talking about it. Does a coordinate exist at? That makes sense. Get coordinate equals null. Not really. Makes sense to you if you're a programmer. It makes sense to me too, I suppose, but it doesn't make sense in conversational English. And you want your code to read, like somebody was reading a book or something. The closer it is to English, the easier it is to reason about, the easier it is to talk and communicate about. So basically all I'm doing here is the, laborious and probably, my apologies, but frankly boring task of going through all these different get piece calls and seeing if any of them are being null checked in a test method or somewhere else. What I'm using there, that pink underline, is code rush. I hit tab and it takes me to the next reference to the method or property or whatever it is I'm doing that for. So instead of assert not null and assert null, I'm saying true and false, and then I'm going to call this new method because in this particular test class, what I'm really testing is move piece. So the get piece or now, does piece exist at, or just my way of verifying the results of my action. And same thing here. This is a test for remove piece, not get piece. So I like this refactoring it, just like the production code. It makes the test code easier to read. I want to assert that it's false that a piece exists at, rather than I want to assert null get piece. And then even here, for remove piece, gets easier to read. If the piece doesn't exist, throw. I guess if you really wanted to, you could have inverse methods. Does piece exist, or is piece missing, or something. I don't know if I want to go quite that far, but maybe you would. So that's about it. I'm going to wrap up here, and I will see you next time around. So thanks for watching, and tune in for episode 20.